we're going to talk about the derivation of the molecular formula from the empirical formula. So, from the empirical formula, we can determine the molecular formula if we know the molar mass of the compound, which is derived experimentally. The molecular formula is defined as the actual formula of a compound as it exists in its most stable form in nature, and therefore its most popular. So as always, we're going to follow a procedure. The first step is to determine the molar mass of the empirical formula, which we can do with the math, and then we can compare and determine relationships between the empirical formula and the molecular formula using this ratio. The molecular mass of the molecular formula over the molecular mass of the empirical formula, which gives us a number called n. And what n is any whole number. And we put the empirical formula on top or below the molecular formula because we always know the empirical formula is going to be equal to or less than the molecular formula. And when it's divided, it's always going to yield us with a whole number. So you might be confused. What is n? So n is, it just tells us how many times more massive the molecular formula mass is than the empirical formula mass, and therefore how many more moles of each element are in the molecular formula, because it follows the law of definite proportions. So to help explain that, I'm going to use marbles. So if we have a bag of 30 marbles that weighs half a kilogram, and then a bag of unknown marbles that weighs 3 times as much at 1.5 kilograms, we can determine how many marbles are in the big bag using a ratio. So, just like we would compare the molecular formula mass to the empirical formula mass and get n, we can compare the weight of the big bag, or the molecular formula, over the small bag, which is the empirical formula, and find out the relationship. And all we have to do is put the big one on top, because it's going to yield us a whole number, and we divide. So, it's going to give us 3. So, the mass of the big bag is 3 times as much, and because of the law of definite proportions, there's going to be 3 times as many marbles. So if there's 30 marbles in the original bag and there's 3 times as much in the big bag, there's going to be 90 marbles. So that is just another way to look at it, help you explain the difference. So here's an example. The empirical formula of a compound was determined to be CH2O, so carbon, hydrogen, and oxygen. Its molecular mass was determined to be 180.156 grams per mole, so it's molar mass. Determine the molecular formula. So first thing we do, the procedure is to determine the molar mass of the empirical formula. So we just take carbon, 2 hydrogens, and oxygen, and we add them up, and we get 30.026 grams per mole. We then use step 2 in the ratio, just like the big bags, and determine how many times greater the molecular formula mass is the empirical mass. And we just divide it, big on top, we get the number 6. We then do multiply all subscripts in the empirical formula by n. Just like we did the marbles, 3 times 30 marbles, because the bag weighs 3 times as much, we do the same thing. So we're going to put a 6 here. Then we just multiply it through all the subscripts. So we get C6, H12, because 6 times 2 is 12, and 6 times 1 is 6. And we're left with glucose. So that's how you derive a molecular formula from the empirical formula. Thanks.